So in this video I want to prove the standard equation for an ellipse centered at 0. So I'll draw a graph here, and if we have our ellipse, it looks something like that. It's not drawn perfectly. Let's say our center of our ellipse is at the origin 0, 0. Well, let's label our important points on this. We'll say that here at the end of the ellipse we have what is called the vertice. The vertice will be a distance from the center, so that's the point A0. And likewise on the other end it will be a distance going in the negative direction, so it's negative A0. As we go vertically, we'll have our top point here. We'll say that's B distance from the center, and likewise going down it's negative B. Now we're going to have 2 points that are lying on our major axis, which will be the x-axis with it centered there. These 2 points are called the foci, and they're going to be C distance from the center, so that'll be C0 and negative C0. So we may ask, okay, well, how does A, B, and C relate? Well, on an ellipse, the focus, or the focal length, how far we have to go from the center to the foci, is C distance. Well, C squared is going to equal A squared minus B squared. So we can use that information and we can derive our formula for an ellipse, because an ellipse is defined as being the set of all points on a graph where I can draw a line to each of the focuses, or each foci, and the sum of those 2 distances will equal some constant. So if, say, I have a point here on the ellipse, and I'll call that point xy. If I draw a line to this focus, then draw a line to that focus, the sum of the distance of these 2 lines will be equal no matter where I go on the graph. So if I have another point, and we'll call this, say, x sub 1, y sub 1, when I draw lines to each focus, this distance, or the sum of the distances of those 2 lines, will be the same thing as the sum of the distances of the other 2 lines. So if it's going to be some constant value, we may ask, well, what will that value be? Well, let's think for a moment. If we're going from the point A0 and we want to draw lines to each of these foci, if I draw a line to the nearer one there, the distance of that line is A minus C, because the whole axis from the origin out to A0 is A distance. The focus is C distance away, so the distance between A and C will be A minus C. Well, a line from that point A0 to my other focus out here, that's going to be A plus C distance, because it's A distance back to the origin and C distance to get to the focus. So if I add those 2 together, what am I going to get? The C's will cancel and it'll be 2A. So what this is telling us is that for an ellipse, any point on the graph, I can draw a straight line to each of the foci, and if I add together the distances of those lines, it will equal 2A. So from that, I'll ask the question, well, what is the standard equation for this ellipse that's this set of all points where the sum of these distances equals 2A? Well, let's try to see if we can figure that out. So if we want to know what these distances are, we'll use our distance formula, which is really just coming from the Pythagorean theorem. That's our change in x squared minus our change in y, or plus our change in y squared. So with that formula in mind, what's the distance from some point xy to each of the foci on this graph? Well, that'll be the square root of my x sub 2, which I'll use my x point, minus, what's the x coordinate of one of the foci? We'll use the first one, we'll use our point C0. The x coordinate C. And what's the y coordinate? 0, so it'll be y minus 0 squared. So this is the distance of that line. Well, if I add the other line to it, what is the distance of this line here? Well, that'll be our x coordinate minus, in this case, negative C squared plus our y coordinate minus the corresponding y-coordinate of the focus, which is 0 squared. So this is representing the distance of those two lines added together. And we know that'll equal our 2a value, which we found here. So if we simplify this, that'll be the square root of x minus c squared plus y squared plus the square root of x plus c squared, because two minuses will make a plus y squared, and that will equal 2a. So now if we can just do the algebra to manipulate it, we can find our standard equation for this ellipse centered at 0, 0. So first thing, let's take one of these radicals and bring it to the other side of the equation. So that leaves on one side the square root of x minus c squared plus y squared, and on the other side it will be 2a minus that square root of x plus c squared plus y squared. So now if we square both sides of the equation, on the left we just get rid of our square root and we're left with x minus c squared plus y squared. On the other side we have to multiply this out, so when we FOIL it we'll get 4a squared minus 4a times the square root of x plus c squared plus y squared, and then we'll have that square root squared, which just clears the radical, and it's plus x plus c squared plus y squared. So now we have a pretty lengthy expression here, but let's go ahead and multiply it out some more, and you'll see we can start canceling terms. So when we multiply this out, we'll get x squared minus 2xc plus c squared plus our y squared that remains there. It's equal to 4a squared minus 4a times that square root still sitting there of x plus c squared plus y squared. And then when we multiply this term out, we'll get plus x squared plus 2xc plus c squared, and then there's still this plus y squared setting out here. So then what can we do to simplify things? We have x squareds on both sides we can subtract and cancel out. We have y squareds on both sides. We have c squareds on both sides. You see we have a plus 2c here. We have a minus 2c there. So if we subtract that one over to the other side, we'll have a minus 4xc there. And if we subtract this minus 4, or the positive 4a squared, subtracting it gives us minus 4a squared equal to our radical that's left over here. So now what can we do to further simplify it? First, let's go ahead and divide out negative 4. So we divide by negative 4 on each term, and that will simplify things where we have simply xc plus a squared equal to a times the square root of x plus c squared plus y squared. So now we're starting to get somewhere with this. To clear that radical, let's square both sides of the equation again. So squaring both sides produces x squared c squared plus 2xc a squared plus a to the fourth, and that'll equal a squared times the square root of that radical, which is simply what's left underneath it. So now let's go ahead and expand this out and see what we get. So the left side will remain the same, x squared c squared plus 2xc a squared plus a to the fourth. That is equal to a squared times, when we multiply that term out, we'll get x squared plus 2xc plus c squared, and then plus our y squared still sitting there. And if we multiply through, leaving the left side alone, it's x squared c squared plus 2xc a squared plus a to the fourth equal to a squared x squared plus 2xc a squared plus a squared c squared plus a squared y squared. So now what can we do to try to simplify from here? Well, you see we'll have some terms we can start canceling out. Let's see, we have actually before we can cancel terms, we can cancel our 2xc a squareds there. And next we're going to have to make a substitution because we said c squared was equal to a squared minus b squared. So let's make that substitution in and see what we get. It'll be x squared times c squared, which we said was a squared minus b squared. And then we'll have our plus a to the fourth remaining out there. That's equal to a squared times x squared plus a squared times c squared, which again is a squared minus b squared, and then plus a squared y squared. So to further simplify, let's go ahead and multiply through on that. So we'll get x squared a squared minus x squared b squared plus a to the fourth equal to a squared x squared plus, multiplying through, that'll be a to the fourth minus a squared b squared, and then a plus a squared y squared. So now what can we cancel out to simplify things even more? Well, we have a to the fourth on both sides. We can subtract and cancel that out. We have an x squared a squared on both sides. We can cancel those out. And we'll be left with negative x squared b squared is equal to negative a squared b squared plus a squared y squared. Now we're almost home. So if we take this term and add it to that side, we'll get 0 equal to negative a squared b squared plus x squared b squared plus a squared y squared. Then if we take this negative a squared b squared and add it to bring it to the other side, we will then get positive a squared b squared equal to x squared b squared plus y squared a squared. Now we're almost home. If we divide by a squared b squared on both sides, what do we get? Well, on the left side that's simply 1. On the right side our b squareds cancel there and it's x squared over a squared plus our a squareds cancel there and it's y squared over b squared, which is our standard form for an ellipse. So if we think back on our original graph and what we have in that, this ugly graph here that we have represented can be said that it's the set of all points where we draw two lines to the two foci and the sum of their distances is 2a. Well, that graph is represented by x squared over a squared plus y squared over b squared is equal to 1, our standard ellipse centered at the origin.